You know that feeling, right? You're staring at the screen just waiting for that stupid progress bar to move, or for a video to finally stop buffering. That lag, it feels like one single annoying problem. But what if I told you it's not one thing at all? Today, we're going to peel back the layers on what's really going on in those moments after you click. It's probably the simplest thing you do online. You do it hundreds of times a day without even thinking about it. But in that tiny fraction of a second, in the blink of an eye between your click and what you see on screen, your request gets bundled up and sent on this crazy journey with all these hidden speed bumps. So what is actually happening in there? So here's the big secret. The lag you feel isn't one delay. Nope. It's actually the grand total of 4 separate, distinct delays that every single piece of your data has to fight its way through. And if you want to understand why the internet can feel slow, you've got to understand these 4 hurdles. Okay, let's dive right in. Every stop your data makes on its journey, like a router, is called a node. Think of it like a rest stop on the information superhighway. And the total delay at just one of these stops is made up of these 4 parts you see here: processing, queuing, transmission, and propagation. For this explainer, we're going to tackle the first 2. And this right here shows you what that journey looks like inside just one router. A little packet of data shows up. First, it gets its papers checked. That's processing. Then, if it's busy, it has to get in line. That's queuing. After that, it gets loaded onto the outgoing road. That's transmission. And finally, it actually travels down that road, and that's propagation. 4 steps, every single time. Okay, so let's zoom out for the big picture. Your data isn't just making one stop. It's making a whole bunch of hops from router to router to router to get where it's going. It's more like a road trip with a bunch of layovers than a direct flight. And every single router adds its own little bundle of these 4 delays. So today, let's focus on the first 2 and really understand them: processing and queuing. All right, let's get into the first piece of the puzzle. We'll start with the easy one. This delay is, by far, the fastest, the simplest, and the most predictable of the bunch. This is the processing delay. So what is it? You can think of it as the router's paperwork. When your data packet arrives, the router has to take a quick look at the address label, or header, to figure out which road to send it down next. It also does a quick check to make sure the data isn't corrupted along the way. And when I say quick, I mean ridiculously, mind-bogglingly fast. We are talking about microseconds here. That's millionths of a second. So in the grand scheme of your total wait time, this part is almost always completely insignificant. Here's the best way to picture it. Imagine a postal worker who's a total speed demon. A letter comes in, they glance at the address, and flick, it's in the right slot instantly. It's a tiny, fixed amount of work for every letter, and it happens so fast it barely even registers. Okay, so we've covered the easy part. Now for the main event. This next delay is the real troublemaker. It's, as our source material says, the most complicated and interesting part of the whole equation. This is where almost all the lag we actually feel comes from. Queuing delay is, well, it's exactly what it sounds like. It's the time your data spends just sitting around, waiting in line. Unlike that tiny, predictable processing delay, this one is a total wildcard. It all depends on one simple thing: how much traffic showed up right before you did. The supermarket checkout is the perfect analogy. The router's outgoing connection is the cashier. If you walk up and no one's there, great, your queuing delay is 0. You're right through. But what if a tour bus just unloaded 50 people with full carts right in front of you? Yeah, you're going to be waiting for a while. That's queuing delay. And we can actually put a number on this. It's a simple ratio called traffic intensity. All it does is compare how fast data is arriving at the router to how fast the router can actually send it out. Basically, it's the number of cars trying to get on the highway versus how many cars the highway can actually handle. And this graph, oh man, this graph tells the entire story. Look at the left side. When the traffic intensity is low, when the highway is maybe 80% full or less, the delay is tiny, it's manageable. But look at what happens as we get closer and closer to 1, when the highway is almost completely full. The delay doesn't just get bigger, it absolutely explodes. It shoots straight up towards infinity. Let's watch it happen. So with light traffic, you see the packets just cruise right on through. The line is empty, no problem. But now watch this. A whole clump of them arrive at the same time. Bam! Instant traffic jam. A queue forms, and now everybody has to wait. See, internet traffic isn't a nice, steady stream. It comes in these bursts, and that's what creates these frustrating backlogs.
So we have one delay that's super fast and totally predictable, and another that can be really long and completely chaotic. So what? What does this all actually mean for you when you're just trying to browse the web or stream a show?
This table just lays it all out. Look at the difference. Processing delay is measured in microseconds. Queuing delay can easily stretch into milliseconds. That's 1,000 times longer. One is a fixed, predictable task. The other is a totally random traffic jam. That contrast, that is everything. And believe me, this isn't just theory. Queuing delay is the reason you see that buffering wheel. It's why you're paying in an online game suddenly skyrockets from 30 to 300. It's what makes a video call turn into a choppy, stuttering mess. And if the line gets too long, the router will literally just give up and start throwing your packets away. No joke. So we've broken down the two types of delay that happen inside the router, the lightning-fast sorting and the unpredictable, often painful waiting in line. But that's only half the story. We still haven't talked about how long it takes to push all the data onto the wire in the first place, or how long that data takes to travel at nearly the speed of light to get where it's going. And that is exactly what we'll cover in part 2 when we explain transmission and propagation delay. Stay tuned.